Good afternoon or good evening, everyone. Welcome once more to Educquiz. My name is Chionta Gabriel. I am a third-year computer student in the Faculty of Engineering and Technology, and I am an instructor of mathematics in Educlynk. So today I'm going to do partial fractions. So today I'm going to do partial fractions. We're going to do partial fractions. So what I will do is I'll first briefly introduce partial fractions, give the definition and some explanation. Then we will see the steps for solving partial fractions, which are enumerated here. These are all of the steps. These are all of the steps for solving partial fractions. So the first step we have the numerator degree. The numerator's degree must be less. The second step, the denominators must be factorized. Then we should write the partial fraction form. We should write the equation in partial fraction form. Then we multiply both sides by the denominator. Then we expand and compare the coefficients to find absolute value, or we substitute values to find the constants. Then we write the final simplified expression. Then we see all of the types of partial fractions one by one, which are linear factors at the denominator, then the repeated factors at the denominator, and the quadratic factors at the denominator. Alright, so what is a partial fraction? A partial fraction is just the simplified simplified form of a fraction, of a whole fraction. For instance, you can have a fraction like a fraction like 3 on x plus 2 into x plus 1. So this is a fraction. If you want to represent it in fraction, this is a fraction. Linear. There's no square, there's no nothing like that. So the use of the importance of putting fractions in partial fraction is maybe in the case of integration, which we might do later. In integration, we need, if you have a fraction like this, the first thing you have to do to integrate easily is to put it in partial fractions. So when you have the partial fractions, you will have something maybe like 1 on x plus 2 on x plus 1. This is way easier to integrate than to integrate all of this through integration by part and all of the stuff. So that is one of the many uses of partial fraction. So as I said before, these are all of the steps of partial fraction. So we'll follow these steps using one example. I'll take one simple example, maybe even the one we just did, which was 3 on x plus 2 x plus 1. Okay, so this is an example of the first form. One of the forms is the form of partial fraction having linear factors at the denominator. So we consider this is a linear factor, which is at the denominator. It's a linear factor because it does not have any square value. So this is a linear. So to solve this, from the methods that are given to me, I should first make sure that the numerator's degree is less than the denominator's degree. So this is the numerator's degree. The numerator's degree is 0. The degree just means the highest exponent of x. So the highest exponent of x here is 0 because there's no x. So it is 0. Here we can see the highest exponent of x is 2 because when we multiply this, we will have an x square somewhere. So the degree of the numerator is less than the degree of the denominator here. So the next thing we should make sure is that the denominator is factorized. Here we can see that the denominator is factorized already. So we have the two factors x minus 2 and x plus 1. When we make sure that the first two are done, we can go in the solving steps. So the third one is to write the partial fraction form. So to write the partial fraction form for a linear like this, for linear factors, it is written as a on x minus 2 plus b on x plus 1. So just write a on the first factor plus b on the second factor. As simple as that. So to continue solving, what I will do is I will find the LCM of this. The lowest common multiple of these two will just be the product of the two. So in this case, the product will be x minus 2 into x plus 1. So when I have my LCM, I divide this by x minus 2 to find the first multiple of a. So I have x minus 2 into x plus 1 divided by x minus 2. I can see that this x minus 2 will cancel this x minus 2. So I'll be left with x times 1. So x times 1 will be the first multiple of a. So I'll have a into x plus 1 plus, I'll do same for x minus 1. So I'll still have x minus 2 times x plus 1. Let me just write it back. Divided now by x plus 1. So when I divide, I'll cross multiply, I'll see that this and this will go. I'll have x minus 2 left. So the multiple of b will be x minus 2. So I'll have b into x minus 2. And my LCM is done. So this part did not change. So I keep it as it was. 3 on x minus 2 into x plus 1 is what I have. So for the next step, I'll cross multiply these two and have it as a linear function. So when I cross multiply, this multiply this and this multiply this, all of this. So I'll have 3 into all of this x minus 2 into x plus 1 is equal to all of this times this. A into x plus 1 plus b into x minus 2. All of that into this. When you multiply, you put a bracket outside of the thing to show that it multiplies everything that is here. That's the importance of the bracket. So I write this, I'll have x minus 2 into x plus 1. This are the same, so you can cancel. If I divide all through by x minus 2 into x plus 1, I can divide also here all through by x minus 2 into x plus 1. I can see that this will cancel this. I'll be left here with 3. This will cancel this. I'll be left here with just this expression. So this implies 3 will be equals to this, which is a into x plus 1 plus b into x minus 2. So this is what we are going to have. From here, we can open the brackets. So this will imply 3 is equal to a times x will give ax, a times 1 will give plus a. A times 1 is a. And you have plus b times x will give bx plus b times minus 2 will give minus 2b. That is what we are going to have. So from here, I can put the coefficients together. I can put the equivalent values together. Like I have 3 is equal to, I can put all of the values that have x together and all of the values that don't have x together, put all of them together. So I have 3 is equal to, here I have a plus b all into x, because a has x and b too here has x. So I have a plus b all into x plus, I write what is left, a minus 2b. So I have this. When I have this now, I can, from here, I see that the value that has x here is a plus b. The value that has x on this other side is 0 because there's no x here. So I can say this a plus b is equal to 0 because here x has a plus b. Here x has 0 because it's the same here like 0x. So this a plus b is equivalent to 0. So I have a plus b is equal to 0 because there is no x on this way. So these are the values that don't have any x. The values that don't have any x is a minus 2b. And in this case, a minus 2b equals to 3 because 3, 2 does not have x on the other side. So I can say a minus 2b is equal to 3. So a minus 2b equal 3. So here I have two equations with two unknowns. I can just use any method to solve them. So I can choose to do equation 1 minus equation 2. If I let this to be my equation 1 and let this to be my equation 2, I can choose to do equation b minus 2b, which will be 3b is equals to 0 minus 3 minus 3. So we have 3b is equals to minus 3, which implies if I divide outside by 3, I'll have b will be equals to minus 1 because this will cancel and this will cancel, giving 1. b is minus 1. So when I have my value of b as minus 1, I replace that b in any of the equations to find a. So I choose to replace in equation 1 because it is simpler for me. So when I replace in equation 1, I'll have a plus minus 1 is equal to 0. A plus minus 1 is the same like a minus 1 equals to 0, which implies a will be equals to, I just make this minus 1 to cross and it become plus. So a is equals to 1. So now we have our two values. A is 1 and b is minus 1. So we are practically done. What is left is to replace a, this equation, put our 1 here and minus 1 on this side, and that is all. So our final expression I think I can wipe now. Our final expression would be to write this back. 3 on x minus 2 into x plus 1 is equal to a on x minus 2. So a is 1 on x minus 2. b is minus 1, so I put minus 1 on x plus 1. And this is the final answer. So this is how to solve partial fraction with linear factors at the denominator. So we are going to do another exercise. The other exercise will be 2x plus 3. 2x plus 3 on x plus 1, x plus 2. This is a little bit more complex because there's an x on top, but it's as simple as the other one. So the first thing we check is the numerator's degree must be less than the denominator's degree. Here we can see the highest power of x here. Somebody might think that they have the same degree, but here the highest power of x is 1. So the degree of the numerator is 1. Here the highest power of x is 2 because this x can multiply. So when x multiply x, we have x squared. So the highest power of x down will be 2, which means the first requirement is fulfilled because the highest power of the denominator is bigger than that of the numerator. The second is the denominator must be factorized. So here we consider the denominator must be factorized. The second one is not always the case because you have x squared minus x plus 6. This can be factorized. So if you have a denominator like this, like this, you must factorize it, have the factors before solving. So well, this can be factorized and you have the factors. As the other one, what we will do, we write this in the partial fraction form. This will just be a on x plus 1 plus b on x plus 2. So as we did before, we'll just find the LCM. It will be the product of the two denominators in this case. It is x plus 1 into x plus 2. So I do this divided by this to find the first multiple of a. So I have x plus 1 into x plus 2 divided by x plus 1. I do this divided by this and I multiply times by a to have the first value here. So when I divide, I consider x plus 1 and x plus 1 will cancel. So I'm left with x plus 2. So I'll do x plus 2 times a, or a into x plus 2 plus I do same with x plus 2 at the denominator. So this will change to 2. And if I cancel, I'll see that this can cancel this. This is not cancelled. I will have x plus 1 remaining because x plus 2 cancels x plus 2. We'll have 1, 1 here. X plus 1 will remain and it will multiply b. So I have b into x plus 1. So we are done with our SCN here. Nothing here has changed. So we write it back. We have 2x plus 3 on x plus 1 into x plus 2. So what we do next is we cross multiply. When we cross multiply, this will come here and this will come here. So we'll have 2x plus 3 into all of this, x plus 1, x plus 2 will be equals to, write all of this times this, a into x plus 2 plus b into x plus 1. All of that times this x plus 1 into x plus 2. So from here we can see we cancel just like in the previous exercise. So this and this will cancel. When we divide all through by x plus 1 and x plus 2, x plus 1, x plus 2, you'll be left with 2x plus 3 is equals to a into x plus 2 plus b into x plus 1, which is just this. So you have a into x plus 2 plus b into x plus 1. Okay, so from here we can open the brackets, or I can show you another method of solving it from here. You can let x to be any random value which will make the equation to be smaller. I can let x to be 0, for instance. If I let x to be 0, I'll write here let x equal to 0. I'll put 0 everywhere. So I'll put 0 everywhere I see x. So 2 times 0 will be 0. 0 plus 3 will be 3. Is equals to a into 0 plus 2. 0 plus 2 is 2. So it will be a into 2 plus b into 0 plus 1. 0 plus 1 is 1, so it's b into 1, or just b. A into 2. Okay. Now I have my first equation, 2a plus b is equals to 3. So this will be my first equation. I can do another let x be equal to 1. When I let x to be equal to 1, I'll put 1 here. 2 times 1 is 2. 2 plus 3 is 5. So I'll have 5 is equals to a into 1 plus 2 plus b into 1 plus 1, which is, well, let me write it. So this will be equals to 5 is equal, this will imply 5 is equals to 2 plus 1 is 3. So I have 3a plus 2 plus 1 is 3. I have 3b. So here when we let x to be equals to 1, we have 5 is equals to a into 1 plus 2, which is it, plus b into 1 plus 1, which is this. So we have 1 plus 2 is 3, which is 3a. 1 plus 1 is 2, which gives 2b. So these are our two equations. So as we did before, we have two equations with two unknowns, which are 2a plus b equals 3 is first equation, and 3a plus 2b equals 5. That is the second equation. So there are many ways to solve it. What I want to do is this is equation 1, this is equation 2. I can do 2 times equation 1 minus equation 2. I can do 2 times equation 1 minus equation 2, or I can do equation 2 minus 2 times equation 1. I do that because I see there is a 2b here and there is 1b here. So if I multiply equation 1 by 2, I will have 2b and 2b. When I'll subtract, the b will disappear and I will be left with a. When I'll be left with a, I'll easily have the value of a. With the value of a, I can substitute in b. So what I do is, I do 2 times this, I'll have 2 times 2a is 4a plus 2 times b, 2b is equals to 2 times 3, 6. I'll do that minus equation 2, which is, I'll just recopy equation 2, which is 3a plus 2b equal to 5. Now I can subtract 4a minus 3a will just be equal to a, equal to 2b minus 2b is 0. So I have a equal to 6 minus 5, which is 1. So I have my first value, a equals to 1. With a equal to 1, I can replace in equation 1 or equation 2. I choose equation 1, it looks simpler to me. So I replace my a equals to 1 here. I'll have 2 times 1, which is, I have 2 times 1, which is 2, plus b and I bring this 2 behind, becomes minus 3 minus 2. So b is equal to 1. So here I see that my a and my b are 1. So I'm practically done. All I have left to do is put the value of a here and put the value of b here to find the answer. So my final answer is going to be, I copy this, 2x plus 3 on x plus 1 into x plus 2 is equal to, my a is 1. 1 on x plus 1 plus my b is also 1. 1 on x plus 2. And here I'm done. So I'm going to give an exercise for you guys to do. So the exercise will be 5 on x squared plus x minus 6. This might look way different from what we have done till now, but you follow these steps correctly, you'll see that the second step is we should make sure the denominator must be factorized. All you have to do is to factorize the denominator and it will be the same as what we have been doing. So this will be a great exercise. So going on to the next type of partial fraction, we have partial fractions with repeated factors at the denominator. So partial fractions with repeated factors at the denominators, these are partial fractions of the form f of x is equal to x plus a all squared plus into x plus b. This is a partial fraction of with the repeated factors at the denominator. You can see that this factor is repeated, is squared. So when you encounter this type of partial fraction, the partial fraction form will be, you have a on x plus a, so this thing alone, plus b on x plus a all squared, now plus c on x plus b. So I have a plus what is inside without the square, then b plus what is inside with the square, then plus c divided by x plus b, the next one. If I do not have any x plus b, I will not have any c. If I add x plus b squared, I'll have c plus this plus a b on x plus b all squared. So I write it first without the square, then I write it with the square. So that is how it is. So we are going to do one example. So as an example, we have 7x plus 4. Further, x minus 3 into x plus 2 all squared. So to solve this, we still look at the steps. For the first requirement, the numerator's degree must be less than the denominator's one. Here we can see that the numerator's degree is 1. So the denominator's degree is 3, because this will be 2 plus this one will be 3. So the first requirement is fulfilled. The second one says the denominator must be factorized. Here in this case, it is already factorized because there is not a square inside, meaning it is factorized. So If the first two are fulfilled, then you can go to the third step, which is to write the partial fraction form. Okay, so the partial fraction form of this will be a on this under, which is x minus 3 plus b on, well, I write it under. Where is it? Back. So it's a on x minus 3 plus b on x plus 2 plus c on x plus 2 all squared. So this is how you are going to write it in partial fraction. So to solve as we did before, we are going to find the LCM. So the LCM, in this case, the least common factor will not just be this times this times this. The lowest common factor will be the lowest common multiple or lowest common factor will be this one times just this one, because you can see that in this one there is already this. In x plus 2 all square, it takes both this and this. So x plus 2 all square can divide both x plus 2 and x plus 2 all square. It is just like we have something, maybe 1 on 2, then plus 2 on 3, then plus 2 on 6. To find the LCM here, we will not just do x minus 3 times x plus 2 times x squared plus 2. Because it will just be x plus x minus 3 times x squared plus 2. Because this already includes this. This one, this x plus 2, x plus 2 all squared, it already includes x plus 2. It is just like you have a fraction like this. To find the LCM, you not just do 6 and 3. This 6 is higher than 3, and it already includes the 3. It is the lowest. So x plus 2 all squared as LCM. So when we do this divided by this, if you do the divisions, if I have x minus 3 into x plus 2 all squared divided by x minus 3 for the first one, I'll say this x minus 3 will cancel with x minus 3, and I'll be left with x plus 2 all squared. So I'll have a into x plus 2 all squared plus this b into, you know what, here the b down is x plus 2. So if I do x minus 3 into x plus 2 all squared, this divided by x plus 2, this one will cancel one of the squares. Because remember, x plus 2 square means x plus 2 times x plus 2. So this will cancel one x plus 2 and will be left just with x plus 2. So the answer will be b times all of this. X minus 3 into x plus 2. Now, plus c into here. Under c we have x plus 2 all squared. So x plus 2 all squared. Keep back my square here. So when I do x minus 3 into x plus 2 all squared divided by x plus 2 all squared, I'm going to have, this will cancel this. So I'll be left with x minus 3 only. So it will be c into x minus 3. So Here I've already found my LCM. This implies this thing does not been changed, so it will be equal to the LCM. 7x plus 4 on x minus 3 into x plus 2 all squared is equals to a into x plus 2 x minus 3 x plus 2 plus c into x divided by x minus 3 x plus 2 all squared. So, following our previous videos, we see that this will cancel this and we'll be left with this is equal to just the upper part. The numerator will be equal to the numerator here. So, if I write it, I'll have 7x plus 4 is equal to the numerator here is a into space will not be enough. I'll have 7x plus 4 will be equals to a into x plus 2 all squared plus b into x minus 3 x plus 2 plus c into x minus 3. Okay, so this is the I'm here B and C. So to proceed with the equation, we have to find the three unknowns. So how do we find the three unknowns? We can see here that we have something with a square, and then we have two expressions which we have to multiply, and then we have this again. So if you want to expand, like this fifth step says, which can expand and compare coefficients. If you want to expand, it will take much time because we'll have very long values here, and it will be tedious. You might find difficulties in doing it, you might confuse. So we can substitute values to find the constants. We can substitute values like now when we can substitute values. Which values? How do we know the values that we have to substitute? We have to look at the equations. We have to look at this expression and see which value we have to put in any of these things so that any of this expression will leave. Like, can I put a value of x to make all of this to turn to 0? Or to make all of this one to turn to 0? Or to make all of this one instead to turn to 0? Is this possible? Here I see that if I put x as 1, will x here make all of this to turn to 0? 1 plus 2 is 3. 3 squared is 9, that will not be 0. So I still have a very long value. If I put 1 here, 1 minus 3 is an answer, 1 plus 2 is still an answer. These answers times b will not be 0. If I put 1 here, it will be the same thing. Same as if I put 2. But if I put 3, for instance, if I use 3, I'll see that 3 here minus 3 will give 0. So I can use 3 because my answer will be a smaller answer because this 3 minus 3 will give 0 and any number multiplied by 0 is 0. So if, for instance, here c times 0 will give 0. So all of this will be 0 if I use 3. That will be the same like here. If I use 3 minus 2 will give 0, which will make b times x plus 2 times 0. All of this will turn to 0. So if I use 3, I will just with 3 plus 2 here, 5 squared 25, 25 times a. So I can use values like that. So let me enumerate the values which will be easy for me to use first. So if I use 3, it will go. I can see that if I use for this one, I've already used 3, 3 will make it to go. For this one, I can see that if I use -2, which number will I put here so that this will give 0? If I use negative, I consider if I use negative 2 plus 2 to add up to 0 to give 0. So I can use negative 2 here so that I'll have 0 here. This expression with A will go. If I use negative 2 here, I also have 0. And 0 times anything, it gives 0. So all of this expression will go to. Then if I use 2 here, I'll have an answer which will reduce this thing to just one answer. So I can use 3, I can use also 2. What other value can I use? I'm seeing here that I have only x minus 3 and x plus 2. That is everywhere. So here I have x plus 2. I have already. That is minus 2, sorry. Yeah, I have x plus 2. I have already my minus 2 to take care of it. Yeah, I have x minus 3. I have already my 3 to take care of it. Yeah, I still have the x plus 2. I have already my minus 2. I have x minus 3. I already have my 3. I have nothing else. But I need 3 equations. So I must use 3 values. If not, I'll have just 2 equations. So the third value is any random value which will kind of reduce a bit the functions. So I can take 0 here because 0 is really easy to manipulate. 0 will be easier than 1 because 1 will add up numbers. I'll have bigger numbers. If I use 0, for instance, here 0 will make 0 times 7 is 8. So 0 will reduce this to 0. I'll have just 4 here. And it will be easier to manipulate because you're not adding, you're just keeping back the values. So these are the 3 values of my selections which I choose to use. So let's start with the first one. We can start with any one, it will be the same. So I choose to start with 3. Let's start with 3. So if I let x to be equals to 3, I'll substitute 3 here. So I'll have 7 times 3, which is 21, plus 4 is just 25. I'll just write 25. Is equals to, if I put 3 here into 3 plus 2 is 5. 5 squared is 25. Into 25. If I put 3 here, 3 minus 3 will give 0. This one will turn to 0. 0 multiplied by any number here will give 0. So I'll have plus 0 here. I can choose to not write it. Same for here. If I put 3 minus 3, I'll have 0. 0 times c is 0 because 0 times any number will give 0. So I'll have 25 is equals to a times 25. If I divide all through by 25 here, I'll have a is equals to 1. As simple as that, I found my first value which is a equal to 1. So I can let x to be minus 2 and find the next. So let x equal to minus 2. I'll substitute minus 2 here. Minus 2 times 7 is minus 14. Minus 14 plus 4 is minus 10. So I have minus 10 is equal to, if I put minus 2 here, minus 2 plus 2 is 0. 0 squared is 0. 0 times a is 0. So all of this will turn to 0 here. If I put minus 2 here, minus 2, this will not make it to be 0. Minus 2 plus 2 here will make it to be 0. So all of this will turn to 0, which means 0 times anything here behind still gives 0. So I'll have 0 from here, 0 from here. If I put minus 2 here, I can see that this can really subtract and not give a value as 0. So minus 2 minus 3 will give minus 5. Minus 5 times c is equal to minus 5c. So I write my minus 5c. So here I see that minus 5 is a common multiple. So I can divide all through by minus 5. Minus 5. I'll have c is equal to, when I divide here I have 1. When I divide here I have 1. I divide here I have 2. Minus 5 divided by minus 10 is 2. So I have my value of c as 2. So I already have a and c. I can now let x to be 0. If I let x to be equal to 0, I'll put here 7 times 0 is 0. 0 plus 4 is 4. 4 will be equal to, when I put 0 here, I will be left with 2. 2 squared is 4. I'll have 4a plus 0 minus 3 is minus 3. Okay, plus b into 0 minus 3 is minus 3. 0 plus 2 is 2. So this is what I'm going to have. Plus c into 0 minus 3 is minus 3. I can just put minus 3c. This will imply 4 is equals to 4a. 2 times minus 3 is minus 6. Minus 6b. And minus 3c. Plus minus 3 is minus 3c. So from here, I can directly substitute my values of a and c. I have a as 1, I can put 1 here. I have c as 2, I can replace my 2 here. And find b. So this will imply 4 is equals to 4 times 1, 4, minus 6b minus 3 times 2 is 6. So I just put my 6. So from here, when I simplify, I'll have 4. I can make 6b sort of formula. If I bring 6b here, if I bring minus 6b here, I'm going to, this minus sign change to plus. I'll have 6b. So I'll have 6b is equal to, when I bring this 4 here, this 4 becomes minus on the other side. I'll first write this 4 here, 4, then I write minus of minus this 4, then minus 6. So which will imply 6b is equal to 4 minus 4 is 0. 0 minus 6 is minus 6. Which will imply when I divide all through by 6, I'll have b is equal to minus 1. So here I've found all of my values. I've had my a to be 1, my c to be 2, my b to be minus 1. So I'm done. I'm practically done. What I have to do is replace them in this form and find my answer. I'll say that to put my final answer, I've had my a to be 1. This is 1. My c is 2. I replace it as 2. And my b is minus 1. So I change this sign to minus. And I put my b as 1. So because b is minus 1, I put minus 1. And that is all about solving the repeated factors. So we are going to do another example, the repeated factors again. So we have x on x minus 1, x minus 1 is up, x squared, x plus 1. So this is also a type of partial fraction with the repeated factor at the denominator, because you can see that x here is repeated. So we have x squared, which is x times x. So x is repeated, x plus the I should just copy it right there. X minus 1, x squared, x plus 1. This will just be equals to a on x plus b on x squared plus c on x plus 1. So I have a on x on this x here, b on the same x but squared. So I have a on x, then b on x squared, which is the repeated factor, then c on the other factor, which is x plus 1. Again, if this was squared, I would have had plus d on x plus 1 squared, and so on and so forth. So, to solve this, as we have been doing, we find the LCM of this. When I find the LCM of this, what will be the LCM? I invite you to pause the video and try to find the LCM of this, according to what we did previously, just the exercise just before this one. So, to find the LCM of this, I can see that I have my LCM will not be x times x squared times x plus. But in this case, that will not be the LCM, because so this x squared already has x. So when we say the least common multiple, the least thing that can multiply these two is x squared. 2 is x squared, because x squared already has x and already has x squared. X squared divided by x will give x. X squared divided by x squared will give 1. So in x squared you already have x. So you just use x squared in x plus 1, you don't have x. You don't have x squared. In x squared, you don't have x plus 1. So you must multiply the two. It's not like this and in a positive answer without the remainder. So I have x squared times x plus 1. That will be my LCM. So to find the first value here, I do this divided by x times a. So this divided by x is x squared into x plus 1 divided by x. This one will cancel, and this one of the squares will go. So I will be left with x into x plus 1. So a times x into x plus 1. This, do you mind the brackets? This is written like this. This without bracket means multiplication. Big a bracket means multiplication too. So I put C choose, remove the brackets. I'll have ax times x plus 1. Or I can still put the brackets, is the same thing. Okay, plus x squared. I will do this divided multiply b. So the b times this divided by x squared. So if I had x squared here, this would have cancelled all of this instead. So even the x squared will go. So I'll be left just with x plus 1. So I put my x plus 1 here, b into x plus 1. Now, plus c into, I do all of this divided by x plus 1. If I do all of this divided by x plus 1, I can see that this will cancel this, and I'll be left just with x squared. So I put c here, this c here times x squared. And that is it, I've done my LCM. Nothing changed here, so I copy it back. I'll have x minus 1 on x squared into x plus 1 as equal to that. So as we did in all of the previous videos, in all of the previous exercises, we cross multiply here. When we cross multiply, we will see that this will cancel with this. When you cross multiply, as we did in the previous exercise, we will see that this will cancel with this, and we'll be left just with the numerators. So the numerators will be x minus 1 is equals to a into x plus 1 plus b into x plus 1 plus c into x squared. Yeah. So from here, I can choose, I'll still let values. So here, as we did in the previous exercise, we find values that when we let the values to be maybe something, they are going to remove one of the constants, either C or B or A. So you look at maybe C. If you look at, okay, let's take for instance the values are next to A. Which value can I put? I can put 0. If I put x as 0, I can see that 0 times x plus 1, whether x plus 1 is anything, it still give me 0. This 0 times A will still give me 0. So all of these will tend to 0 if I put 0. So I know that one of the values that I'm going to use is 0, because 0 is going to make something to disappear. For instance, here, 0 also going to make something to disappear. At least it is making one thing to disappear. In this case, it makes two things. It is even better. So when I see the other factor, the second factor, I see x plus 1. What value of x can make x plus 1 to tend to 0? So you have x plus 1. What value of x will make that x plus 1 to be equal to 0? You can just put it as an equation like this. You find your x will be equal to, when I put this one here, I'll have negative 1. I know then that when I put x as negative 1 here, negative 1 is going to make this to be 0. Going to make this to be 0. And I know that 0 times anything, the overall answer is going to be 0. So that will be the same thing here. If I put negative 1 here plus 1 will give 0. 0 times b will give 0. For instance, if I had b into maybe x plus 2 again, at the place of this, I would have looked for one number that when I put it here, it will make the b to be 0. I would have still done x plus 2 equals to 0. Which number will I put in x for x plus 2 to give me 0? I'll still bring this 2 here. X will be equals to negative 2. And again, when I put negative 2 here, negative 2 plus 2. Swift. If one of the values 0 for this x, then we use negative 1 for this one, negative 1, and 0 still for x squared. So since there are 3 unknowns, we must use 3 equations. So we must use 3 numbers. So the third one that I want to use is 1. I'll tend to use 1 because when I put 1 here, I'll see that 1 minus 1 will give 0. So this thing will tend to 0 if I use 1. It will not turn anything here to 0 because we already have all of the values that will make them to tend to 0. But if I use 1 here, 1 minus 1 is going to give me a 0. So the third value that I'm going to use is 1. So when I have my 3 values, I just start using them. So the first thing I do is I let x to be 0. When I let x to be equals to 0, what do? I replace 0 everywhere I see x. So 0 minus 1 is minus 1. It's equals to, when I put 0 here, I'll have 0 times a will be 0 times x plus 1 will be 0. So I have 0 here, I can choose to not write it. If I put 0 here, I'll have 0 plus 1 is 1. 1 times b is b. If I put 0 here, I'll have 0 squared, which is 0. So 0 times c will give 0. So I can choose to not write it because the answer is 0. So here I'll have, as simple as that, b is equals to negative 1. You see, it is way simpler than if I actually expanded. This expansion and comparison of coefficients is better to be done with linear factors. Yeah. It's with linear factors at denominators. That's when you can expand and maybe have the answers. So when you have found the value of b, you let your second one, I'll let x to be negative 1. When I let x to be negative 1, I substitute my negative 1 in the function. I'll have negative 1 minus 1 is minus 2 is equals to, I put negative 1. When I put negative 1 here, I'll have negative 1 times a. When I put negative 1 here, negative 1 plus 1 will give 0. So since this one is 0, 0 multiplied times anything is still 0. So 0 here is multiplying x and it's multiplying a. So inside the bracket is 0. So 0 times this gives 0. So I put 0 here, or I choose to leave it like that. When I put my negative 1 here, same thing, negative 1 plus 1 will give 0. So in this bracket it will be 0. So 0 times b will be 0, because 0 times any number is a. So I choose to not put it. So -1 here, I put my -1 on this here. -1 squared is 1. 1 times c is c. So I put my c. So as simple as that, I just have my value of c. It will be -2. Just like that. No very big calculation. So the next thing I let my x to be 1. When I let x to be 1, I replace 1 here. When I replace 1 here, I have 0. 1 minus 1 is 0. So when I replace 1, I have 0. I have 0 is equal to a times 1 times a into 1 into 1 plus 1, which is 2, plus b into 1 plus 1, which is 2, plus c into 1 squared, which is 1. That will be equal to 0 is equal to a times 1 times 2. 1 times 2 is 2. So I have 2a. 2 times b is plus 2b, and c plus c. I already have the values of b and c here. B is -1. So I can replace here by -1. I'll have 0 is equals to 2a minus, if I replace here, 2 times -1 is -2. And c is -2 also. So plus c is -2. I just replace my c by -2 directly. So here I'm seeing that 0 is equals to 2a minus 4, which implies 2a will be equal to, when I bring this 4 this way, it becomes positive 4, which implies a will be equals to 2, which is, if I divide all through by 2, I'm going to have a as 2. So I easily found my values of a, b, and c. So I have a as 2, b as -1, and c as -2. So my final answer, I'm going to have this. I can recopy it. In your book, you have to recopy it here. They'll just replace here. A is 2. B is -1. So I change the sign here to minus and 1. And C is -2. I also change the sign -2. But in your book in class, you have to write it here. Right? We copy this x minus 1 divided by x squared into x plus 1 is equal to this. Write it like this in your book. That is going to be your final answer. Alright. So here you can see it's really simple. So I'm going to wipe and give one exercise. In this partial pattern, you have to know that when you solve for the values of a and b and c, if you have values like 17 and 25, you have to check back your work. You very rarely have this kind of values which are correct. I didn't say it's impossible, but it's really very rare. So if you have this type of value, you have to check back your work. You can, at the extremes, you can have maybe half or 1 on 6. When I start having 7 on 15 like that, start checking back your work to see if you have done an error somewhere. So, the exercise I'm going to give is x squared minus x minus 4 divided by x minus 2 cubed. Yeah, so you have to do this at home and leave the answer in the comments if possible. So I'll give you a small hint here. You have to use all of this. You have to make sure that the numerator's degree is less than the denominator's degree. Here we can see that the numerator's degree is less. The numerator's degree is 2. The denominator's degree is 3. So we can see that it is less. Then you make sure that the denominator is factorized. Here we can see it is factorized, then it's factorized. Then you write the partial fraction form. So I'll just help you with the partial fraction form. Nah, I won't help you. You have to know. So make sure you find it. Okay, so going with the third and last type of partial fraction, we have partial fraction with quadratic factors at the denominator. So partial fractions with quadratic factors at the denominator is partial fractions of the form q of x over x to x squared plus mx plus n, where like this, where you have something that can be factorized and something that cannot be factorized, and maybe just this, you must not be multiplied by anything else. You use this third form. So when you encounter this, your partial fraction is going to be a on x plus a, like we have done normally, plus bx c in x squared plus ms plus n. Yeah. So if you had here, this should be squared and x plus g. As simple as that. So let's solve some examples. We have yp. We have 2x minus 1 all in x plus 1 into x squared plus 2. So how do we solve this? We firstly make sure that the numerator's degree must be less than the denominators. After all of this, I'm going to solve those miscellaneous exercises. I'm going to solve cases where the first condition is not respected, the second condition also is not respected, so that you see what to do when those two conditions are not respected, because till now we have just solved equations where the first two conditions are respected. So on the miscellaneous, we are going to see them. So we check the first condition, we see that it is respected. Here the numerator's degree is less than the denominator's degree. On the second one, the denominator must be factorized. Here we see that it's factorized. Here this is not factorized, but it cannot further be factorized. X squared minus 2 cannot be simplified further. So we just leave it like that. So anytime you see something that cannot be factorized, you know that it is the partial fractions with quadratic function, with quadratic denominators, the rule for A that we are supposed to use. So the first thing that we do, we write the partial fraction form as the step 3 says there. The partial fraction form, how do we write it? We write it as A on x plus 1 plus bx plus c on x squared plus 2. As simple as that. From here, we just solve normally as we knew how to solve. People will say, okay, because it is x, it's kind of difficult to solve. Well, we're going to see how easy it is. So here, as we keep doing, we just find the LCM. LCM will be x plus 1 into x squared plus 2. When we find the LCM, we divide this by this and multiply by this. So this denominator divided by x plus 1 will be x plus 1 into x squared plus 2 divided by x plus 1. So when we divide this, we can see that this is going to cancel this. So we have 1 up here. So it will be left just with x squared plus 2. So x squared plus 2 times a will be a times x squared plus 2 plus, I'll do same, I'll divide this by this divided by. So instead we see that this will cancel this and we'll be left just with this. So we will have bx plus bracket here to show that it is all of this that is multiplied by x plus 1. If I don't put the bracket, because this is one error that many students do, they omit the bracket because they say, well, there was no bracket here, I don't need to put the bracket. If I leave it like this without bracket, this will imply that c is multiplying it is just c that is multiplying x plus 1. It is not actually all of this. That is why I should put the bracket. The bracket means all of what is inside the bracket. So never forget that. Okay, so when I've done my LCM, I can copy back this. Nothing here I've changed. I have 2x minus 1. Put my equal sign. X plus 1 into x squared plus 2. Okay, so from what we have been doing, we see that this down part, they will cross multiply. When they cross multiply, this one will come up, this one will come up. When we divide all through by x plus 1 into x squared plus 2, this will cancel the other part there. So that's what we have been doing. So I won't go through all of the steps again. So I write the numerators. I'll have 2x minus 1 is equal to a into x squared plus 2 plus bx plus c without forgetting the bracket into x plus 1. So when I have this, I can now choose to either expand the bracket, expand because that is the fifth step, expand and compare coefficients, or I can choose to substitute values to find the constants. So here you can do anything that you want to do. It will be approximately the same difficulty. So anything that you choose will be fine. Anything that any step that you choose is going to be fine. It's approximately the same difficulty. I will choose to substitute values still. I find it better. You can choose to do something else to expand and compare the coefficients. It will still be better. You have done it in our very first example, we did it. So if you don't know how to do it, you can go to the first example and find it there. So when I substitute, what did we say about substitution? We said we should find values of x. Then when we put here, we are going to have 0. And then it is not in all the cases that you will find values of x. Then when you put here, or here, you will have automatically 0. It's not always the case. So it's better to use this method when you know that at this one value of x, you put at this one value, you will remove everything at this one. If you see that there is no value, it is not possible for any value of x that you put here that will remove everything or one of the expressions. The substitution, the expansion and comparison method. You just expand it, do a times x squared, a times 2, then you multiply it step by step and compare the coefficients. So in this case, I check here, what value of x can I put here that will give me 0 here in this x squared plus 2? I see that, okay, let me try to find the value. Have x squared plus 2 is equal to 0. If I solve, I'll put this here. X squared will be equal to minus 2, which implies x will be equal to square root of minus 2. This is already a complex number. This is equal to 2i, which we cannot use in this. We are going to do complex numbers as time goes. This is not more the scope of partial fractions. but we cannot use it here. So you can see that here there's no value. We continue with this one. Which value of x can I put here that will give me 0? I find as x plus 1. Which value of x plus 1 will I put that will give me 0? So I find x will be equals to, I bring this plus 1 here, I'll have minus 1. I can see that x as minus 1 make all of this to be 0. So I'll use my x as minus 1. So one of the values of x I'll use is minus 1. But I need 3 values of x because I have 3 equations. So the second value of x that I'll use is, I'll be tempted to use 0. Because 0 is a value of x which is really easy to use. You can also see that 0 here will make this be. So I can use 0. That will be the second value of x that we use. As third value of x, so people will be tempted to make this to be 0. If I make this to be 0, I'll have 2x minus 1 is equals to 0. I'll have 2x is equals to, when this one crosses, it becomes 1. I'll have x to be equals to, I divide all through by 2, and I have half. But people will be tempted to put half here, but if you put half here, certainly you have 0 here. But you start having 1/4 here, you have 1 on 4. 1 on 4 plus 2 will be just to add. You have 1 on 2 here, 1 on 2 here, 1 on 2 plus 1, you have 3 on 2. You start working with fractions. So it is true, make this one to be 0, but if it is a fraction that makes something to be 0, better not use it. Better use something like 0 or 1, especially when you have already 2 values that are already giving 0. But as I said, if you have no value that gives you 0 here, don't use substitution. Just expand it normally and compare the coefficient. Don't use the substitution. So the next thing I will be tempted to use, since no other value, I'll be tempted to use 1. Small value which I can use. If you find it more easy for you to use -2, use it. If you find it easier for you to use 2, use it. I find it easier to use 1, so I'll use -1, 0, and 1. So I have my 3 values that I can solve using those 3 values. I'll let x first to be -1. When I let x to be -1, I replace my -1 here. I have -1 times 2 is -1 minus 1, -3. -3 will be equals to a into -1 square is 1. 1 plus 2 is 3. Plus b into -1. -1 times b is minus b plus this c times -1 plus 1. You can see that -1 plus 1 here will cancel. -1 plus 1 will give 0. So 0 times anything here will still be 0, because 0 is not just one part. This is also one error that students do. Students just assume that it is just one part that will give 0. And since it's just one part that will give 0, it will be 0 plus 1. And then all of this will be still this. But if you have 0 inside everything here, inside this bracket, if this whole bracket is changed to 0, it is 0 times any other thing that was behind. If there was anything behind, it would be 0. Except if you have plus something without a bracket. If there's no bracket here, if it is plus here. In this case, if you had a plus here, if you had a plus before the bracket, you cannot just multiply because it's this plus that separates. So if you have any plus, 0 times anything that is behind or after is just 0. So here I have 0. 0 times anything here is just changed to 0. So here I'm left with a is equal to -3 is equal to 3a. Which implies if I divide all through by 3, I'll have a is equal to -1. So that is our first value of a. So I let x to be 0 to find the next value. Letting x to be equal to 0, I replace it here. I have 2 times 0 is 0. 0 minus 1 is -1. Is equal to, letting x to be 0 here, I have 0 plus 2 is 2. 2 times a is 2a. and I put 0 here, 0 times B is 0. 0 plus C is C. Here we can see that this 0, let me just write it, plus B into 0 plus C into X plus 1. Since I let X to be 0, this X will be 0 plus 1. Here multiply 0. It is not all of this that is 0. So you not say that since there is 0, everything here will tend to 0. It is just B that will be 0. You just this 0 multiplies just B. So this will be equivalent to minus 1 equals to 2A plus B times 0 is 0. 0 plus C is C. Here you can choose to remove the bracket because you have just one expression left. If you have two expressions, then you must put the bracket. If you have cross A, you must put the bracket. Since I have just C left, I can choose to remove the bracket. Or if you put the bracket, it is not wrong. You can still choose to put the bracket. Times 0 plus 1, C times 1. Since there is one expression, I can choose to remove the bracket or to put the bracket. Is the same thing. So I have minus 1 is equals to 2A plus C. C times 1 is C. I've had my A to be minus 1. So I can replace A here by minus 1. I have minus 1 is equals to 2 times minus 1 is minus 2 plus C. Now when I bring these two here on the other side, I'll have minus 1 plus 2 is 1 is equals to C. Or C equals to 1. I choose to put it in this form. C equals to 1. So I have my value of A minus 1, C to be 1. I can now let my X to be 1 to find the value of B. So when X is 1, I can put the 1 here. 2 times 1 will be 2. 2 minus 1 is 1. I have 1 is equal to A times 1 squared. A into 1 squared is 1 plus 2, 3. Plus bracket B times 1B plus C into 1 plus 1, 2. So this is what I have. When I simplify, I have 1 is equals to 3A. 3 times A is 3A plus. If I open this bracket, I'll have 2B plus 2C. B. So I can leave like this. But I already have the value. So I can replace my C and A here. I'll have 1 is equals to A is minus 1. Minus 1 times 3 is minus 3 plus 2B plus 2 times 1 is 1, is 2. So when I simplify, I have 1 is equals to minus 3 plus 2 is minus 1 plus 2B. So when I bring this one here, and I bring this one this way, it becomes plus. 1 plus 1 will give 2. 2 is equals to 2B, which implies B could be equals to 1. To have 1, I divide both sides by 2. I have B as 1. So we have our values. C is equals to 1, B is equals to 1, A is equals to minus 1. We can just put our final answer as, I can just replace them here. My A is minus 1, minus 1 plus B is 1. B, 1. Or 1 times X is just X. We can just leave it as X. Plus C is 1, 2. So this is what my answer will look like. But in your book, you have to write the final answer as, we recopy this again. So I didn't put the equal to sign. You recopy all of this again. Then you put equal to, you write this answer on this answer, replacing your A, your B, X, and your C. you write it under here. You don't come and write it here. Write it under. Okay, so this is the second exercise on partial fractions with quadratic factors at the denominator. So here you can see that it cannot be factorized. So we use all of these rules. The first condition is the numerator's degree must be less than the denominator's degree. You can see here that the numerator's degree is 1. The denominator's degree is 3, because when we multiply this with this, I'm going to have the highest degree to be 3. So the first condition is fulfilled. The second condition says the denominator must be factorized. Here it's already simplified at its highest. This one cannot be further simplified. So the second condition is already fulfilled. From here, third one, you write the partial fraction. You write the partial fraction form. Okay, so the partial fraction form of this is a on x minus 1 plus bx plus c for this one, which is plus 1. So as we said, quadratic expression, you write it in this form. So the next step says multiply both sides by the denominator, where we're going to do r. Before doing that, you have to find the LCM. The LCM of these two will just be the product of the two. You have x minus 1 into x squared plus x plus 1. Okay, when we do this divided by this denominator, let's do it. You have x minus 1 into x squared plus x plus 1. We have to do this divided by this to have the answer multiplied by a to have the first expression here. You have to do this divided by this to have the answer multiplied by bx plus c to have the second expression here. That's how we have been doing. So you do all of that divided by the denominator here is x plus x minus 1. Here you can see that this will cancel this and we'll be left with x squared plus x plus 1. So I'll have a into this a into x squared plus x plus 1 plus bx plus c. I put my full bracket. I put this bracket to show that it is not just c that is multiplying, but all of this expression is multiplying. So I put the bx plus c in bracket into all of this divided by this. When I divide all of this by x squared plus x plus 1, I can see that this is going to cancel this. I'll be left with x minus 1, and that is all. So nothing changed here. So I recopy it. I'll have 3x all on x minus 1 x plus 1. When I cross multiply, I'll see that this will come here and this will come here. But these two are the same. So at this level, they will cancel. That's what we have been doing since. So do the cross multiplication and check that these two are going to cancel. So when they will cancel, we'll be left with 3x is equal to this upper part. This upper part is a into x squared plus x plus 1 plus bx plus c into x minus 1. So we have this. Okay, so for this time, I really want to expand and compare. Beneficial to me is because I've not done it for a while. People also have to know how to do all of the methods. So I'll do the expand and compare coefficients method. That's the method that we used here. So what I'll do here is I will just open the bracket. So I'll have 3x is equal to a times x squared is ax squared plus a times x is ax, a times 1 is a, plus bx times x plus bx times minus 1 is minus b. C times x plus cx, c times minus 1 minus c. So when you expand like this, when you use the expansion method, when you expand like this, bring the like terms together. So you bring together, I have nothing together. So I bring everything that has x squared together. I'll have a plus b. That is all that has x squared. I put into bracket x squared. So I check what has x squared. I can see that a here has x squared. I can see that b here also has x squared. What else has x squared? Nothing. So I put my a plus b all into x squared. Because when I expand, I'll have ax squared plus bx squared back. So what I do next is I find the value of x that have just x. The values that has just x, I put them together. What has just x? I can see that a has x, ax. So I put plus, I put my bracket, I put a, because a has x. What else has x? I can see that c has x plus c, and that is all. Those are all of the values that have x. I close my bracket and I put x outside. Then I complete with the values that have neither x squared nor x, the values that have nothing as coefficient. So I have a, I have minus b, and I have minus c plus a minus b minus c. So this is just the equivalent of this, the same thing. So the next thing that I do is, as the thing says, we expand and compare coefficients. So we have finished expanding. Now we can compare the coefficients. The coefficient of x squared here is a plus b. What is the coefficient of x squared on the left side? Consider nothing on the left side has x squared. So the coefficient of x squared on the left side is 0. So I can say from here, a plus b is equal to 0. Because a plus b here, the coefficient of x squared on the right side is a plus b. The coefficient of x squared on the left side is 0. So I say a plus b is equal to 0. I say that the coefficient of x squared on the left side is 0 because there's no value here on the left side that has x squared. I can see just something having x, but not anything having x squared, so I take it to be 0. So here, the coefficient of x on the right side is a plus c. So I write a plus c equal the coefficient of x. We have 3 behind x. So the coefficient of x on the left side is 3. So I have a plus c, which is the coefficient of x. That is my second equation. Now, the coefficient of here, these things don't have any x, nor any x squared. So here, you can see on the left side that there is nothing that has no x, because the only thing that is on the left side is something that has an x, and it is 3. So we can see that here, for terms that have no x, on the left side is equals to 0, because on the left side there is no term that has no x. So you can say a minus b minus c equals to 0. So these are the 3 equations that we are going to be using. So I have 3 equations with 3 unknowns. I can use I can add equation 1 and 2, the first and the second equation, to compare with the third equation. If I do, let me enumerate this to be equation 1 and this will be equation 2. And this will be equation 3. If I do equation 1 plus equation 2, I'll say that a plus a is 2a. B plus 0b is just b. So you have plus b plus this c to be equals to 0 plus 3 is 3. So this is the equation I will have, and then I will copy this last equation. I have a minus b minus c. A minus b just to add these 2 equations. when I add these two, I choose to add the two equations because I know that when I add, I'll have b minus c. I put the plus here, I have b plus minus b will give me 0. I have c plus minus c, I'll still have 0. That is why I choose to. When I add, I have 2a plus a is 3a. b plus minus b is 0. C minus c is 0. 3 plus 0 is 3. So I have my a to be equals to 1. That will be the value of a. So when I have a, I can replace my a in equation 1 here or equation. This is my a in equation 1. When I replace my a in equation 1, I have 1 plus b equals to 0 because it says a plus b equals to 0. So I can choose to put a plus b equals to 0. I choose to put 1 plus b equals to 0. So when I do so, I have my b as, when I bring this one behind, that is my value of b. So I have a and b, I just have to find c. From equation 2 here, I can find, from this equation 2 here, I can find c because I have my a to be 1. I'll put 1 here, I have 1 plus c equals to 3. So I'll write it here, 1 plus c equals to 3, which implies c will be equal to, c is equal to negative. This positive here, 1 here, when it comes behind, it becomes negative. 3 minus 1, which implies c is equal to 2. So now we have found our values of a, b, and c successfully. We see that it was quite easy. You see the difficulty on expanding and comparing is not that much different. It's not that much more than the difficulty in substituting. So one might choose to expand every time and compare. One might also choose to substitute. It will not take you more time. It will not take you that much more time. It is approximately the same difficulty. So when you have your values of a, b, and c like this, what you do next is you recopy this and write the answer. So I'll just write it here. I'll write 3x on x minus 1. X squared plus x plus 1. 3x on that is equal to a on x minus 1, where my a is 1. X minus 1 plus bx plus c. My b is minus 1 plus I have minus 1 x. Minus 1 times x is minus x plus x squared plus x plus. So here I'll put the value of a, which is 1 here. I'll put the value of b. B is minus 1. Minus 1 times x is minus x. Plus we have put the value of c. C is 2 divided by x squared plus x plus 1. If I choose to read your answer like this, but if you want to show your teacher that you really know, then you are going to switch these two. Because it is not really nice that a fraction starts with a negative when there is a positive that is empty behind. So you could put it as 1 on x minus 1 plus, you put this plus here, then you put 2 minus x. You put the 2 first minus x. Addition and subtraction is commutative. Whether you do 1 plus 2, it's the same thing like you do 2 plus 1. Same like minus. If you do 1 minus 2, it's the same thing like you do 2 minus 2 plus 1. If you do 1 minus 2, it's the same like minus 2 plus 1. These two are the same. You just switch one number. So if you do minus x plus 2, it's the same like you do 2 minus x. The same. So just put it like this on x squared plus x plus 1. And you are done. We're good to go.